Altair is an LT chip company. We've been around for 10 plus years. Our strategy from day one was focused around developing high performance and yet very cost and power efficient LT only chipset, as opposed to chipsets that have fallback to 2G and 3G and older technologies. I guess that until maybe 2 years ago or so, most of our business was centered around broadband products and things like computing platforms, tablets, Chromebooks, netbooks, gateways, CPEs, MiFis, dongles, and such. And these were category 3 and above, so 100 plus megabits per second. Pretty obvious use case. The value proposition has always been, it's a great chipset, works well, very low power, but lower cost. Right? That was really the main selling point, because it did not support 3G and 2G and these older technologies. But about 2 years ago or so, we identified that there was a need for a long-range wireless technology to connect a very wide range of what today is known as IoT applications, previously M2M in a sense. And back then, the LT standards were not as well developed in the lower categories as they are today. There was only a variant known as Category 1. It's 10 megabit per second downlink 5 up. But we figured that from a standards progression perspective, there was going to be at least 3 to 4 year window of being able to ship a product. We designed a dedicated, optimized chipset for Category 1, whereas most of the other players in the market basically said, it's an interim thing. We'll basically just remark our Category 4 chipsets, sell them at a discount, and migrate into the next generation, which I'll talk about in a second. But basically, that turned out to be a pretty big advantage for Altair in the market, because today we have chipsets that are extremely small, extremely low power, and this maybe ties into some of the activities that we've done with Ericsson, AT&T, and some other partners, Verizon as well in previous conferences. We've shown that a Category 1 chipset with power save mode and extended DRX can achieve more than 10 years worth of battery life. Of course, depending on the scenario. If you have a wearable device that has to be idling all the time and listening, it may last for weeks. But if you have a smart meter that needs to wake up once a day, transmit 100 bytes, and go back to sleep, this is 10 years or more on 2 AA batteries. So a pretty significant power reduction compared to higher categories. Cost, which was announced, I think today or yesterday in the AT&T Developers Conference. They announced a $14.99 Category 1 module based on WNC, which uses our chipset inside. So we've also, got the cost down very significantly, and size, which is kind of the third pillar. We have modules which are almost the size of Wi-Fi today. So that's what we have today, and expect to see a bunch of applications in the utilities space, telematics, usage-based insurance tracking, vehicle financing, security system, alarm panels. I mean, every application that needs long-range wireless link and potentially was based on 2G before these networks are being shut off. Needs to migrate to something. There's a big advantage for LTE versus the proprietary technologies, LPWA, like LoRa, Sigfox, etc. Kind of outside the scope of this discussion, but basically, very, very intense level of activity in the channels today. Next generation of products is going to even further improve power efficiency, cost, Category M, narrowband, IoT. These are all part of Release 13 of the standards coming, in a year or so. So there is a pretty robust roadmap for LTE in that whole IoT space. We're in for the long haul. We've proven that we can sustain ourselves and survive in a very highly consolidated market. We intend to stay there. So I think that is a good question, and the answers tend to get a little oversimplified looking at one dimension, which is module cost or chipset cost. People tend to, I think, overrate that. There's a CapEx element, there's an OpEx element, but there's a total cost of ownership, TCO, right? Total cost of ownership, this is what you really have to look at when trying to figure out if a business model works or not, and the module cost is only a part of that. So say, if we were able to reduce the module cost to $1, okay, and the carrier would still charge $10 a month for the service. Obviously, that would be a no start, and the other way around. So there has to be a very fine balance between these two. I think we've solved the chipset part, and when I say solved, I mean that I think we've gotten to a point where, if it's 50 cents more or less, does not fundamentally change, the ROI model and the viability of the business model. There's a lot of work going into reducing the, I would say restructuring the SLAs, the service level agreements from carriers, making it, more like a $2 per year per end device. The combination of these two, I think, and of course a need. There has to be a need. But so far, cellular has just been too expensive, too power hungry, and certifications and provisioning and SIMs, and it's just been a pretty challenging experience for folks. Our aim is to make this thing as simple as Wi-Fi or Bluetooth. Don't have to worry about provisioning and SIMs and it's just so simple. You have an API, connect, disconnect, you talk to the network. There's already, pre-installed cloud clients that enable you to connect to, standard cloud platforms like AWS and Google and what have you. It really has to be simple if we want this thing to get off the ground. And I'm very glad to say that all fronts are moving forward, not always at the same pace, but we definitely see very significant movement forward in that sense.